Hello, this is Peter Larsen from Loudsoft. I will do a demo for you of FINECone designing a 6.5-inch woofer. So we open FINECone, and the first we're going to do is to import a geometry. This can be done by a DXF file. You can see it's very simple. It's just lines and arcs, and this can be created by any CAD program. So we will use this profile, and then FINECone starts calculating immediately. It's almost done. All we need is to give it some basic parameters, and now we can see the calculation is done, and we see the calculated response here. There's a nice range up to around 2 kHz with a peak, and there's another big peak here at 3 kHz. I had also previously made another curve without the dust cap, and this is the purple curve we see there, which does not have the peak. So we'll try and come back to this. So now we can take a look at what's actually happening at different frequencies, because we can animate the movement. This is the real finite element model with all the small elements. Actually, we can hide those and just look at full model. At 20 Hz, everything is moving as intended. The cone is behaving nicely. So let's go and see at some higher frequencies what's happening. At 1 kHz, there's a little bending at the outside, otherwise nice. At 2K, we see here we have real cone breakup in the outer half of the cone. So if we go on at 3K, we can see what's happening there. Oh, there is a lot of action in this dust cap. That's remarkable because we have even selected an aluminium material for the dust cap, but still we have breakup. Now we can go back and then do something about that. We can see that the profile of dust cap is rather flat. So let's change this by importing another DXF file that has a much higher profile. You can see here's the dust cap there in blue. It's much higher, and therefore it has much more stiffness against the breakup. So let's try and use this. We do a new calculation, and this time we're going to watch the curve and see how it will change. Wow, that really made a big difference. Now the big peak is gone, and we are actually quite close to this purple curve that had no dust cap. So this dust cap must be actually performing quite well. Okay, but we don't like this frequency response here. We need to do something about it. And we saw there was breakup at this frequency here. So let's see what we can do with the material. You can see this is the surround, and here's the diaphragm consisting of these 3 segments there. This is here, and it's a polypropylene material which is filled with talcum, and you can see stiffness and mass density and Poisson, that's a constant, and then damping is here. So if we want to do something about this, let's try and change this material. We do have a material database, so we can we can just select another material. There are many interesting materials we could try. Let's try now another PP quality with mica filling. You can see it's much stiffer than before, 9,000 compared to 3,000. So we will try this and say apply, and OK. Now the calculation will restart, and we are going to see what will change this time. Aha, this actually worked quite well, because the peak moved up to a much higher frequency. There's still a little thing happening here, but overall it's a great improvement. Yes, now let's take another look at the animation, and we can go to 2K first and see what's happening there. Aha, now we only have bending of the cone edge happening at 2K. There's no real cone break up there. So we could try and do something about this mode here. And you can see the surround is actually doing a lot or participating in this mode. So why don't we try and change the surround a little? So we go back to material properties, look at the surround this time, and we can see it's a rubber material which has nice damping, but it's pretty thin. So let's try and change the thickness simply from 0.4 to 0.6, say OK, and we do recalculation again. And we see now, wow, this was really effective. So the surround is a very important part of this. And you can see now we have a nice, well-behaved frequency response up to 3K. There's some action here. And so we're going to refine this. I'll just show you the final result here. This time we have used the model here and changed the material to PP also for the dust cap, and now we see the black curve is what we are calculating now compared to the blue curve, which is a real sample we have built and measured, and you can see they are very close to each other. It's not so important that there is 1 or 2 dB difference here, because we have predicted the general shape of the curve, and that's more than enough. So we can see that we have built a nice woofer this way, and it didn't take very long. So this is a successful simulation done in FINECone.